We're going to simplify this trig problem. Simplify sine of theta plus pi over 4. Well, using the sum identity, you get sine cosine plus cosine sine. And you know that the cosine of pi over 4 is square root of 2 over 2. The sine of pi over 4 is square root of 2 over 2, and you have simplified it. The second problem says find the exact value of cosine of 15, which means you can't put it in your calculator. That gives you a decimal value that is not exact because it will have to be rounded. So what we're looking at is probably finding the cosine of 60 minus 45, or you could do the cosine of 45 minus 30. Now, using the difference identity for cosine, what you have is cosine of 60, cosine of 40, plus sine of 60, sine of 45. Those are all special triangles, and so you can say that the cosine of 60 is 1/2, the cosine of 45 is square root of 2 over 2, plus the sine of 60 is square root of 3 over 2, times the sine of 45, which is square root of 2 over 2, multiply the fractions, and this is what you get. And that is an exact answer because there's no decimal that you have to round. The next one that we're going to talk about are graphing. So we're looking at actually graphing y equals sine squared. So what we're going to do is actually graph y equals sine. And you should know how to do this because this is a regular sine wave. It's taking the unit circle and unraveling it. And one complete revolution in the unit circle is 2 pi radians. Now if I'm going to square it, that means everything that was negative is going to come up to the top. And if I had a, let's say I had the sine of 30, which would be 1/2, when I square it, it's 1/4, so it's a little smaller. And so you end up with something that looks like this. Now in pre-calc, we actually developed this identity several times. The cosine of 2a. That's the same thing as saying the cosine of a plus a. So cos minus sine, and you get this identity. Well, there are 3 of them because I can take cosine squared and substitute it with the Pythagorean identity, add like terms, and now I get 1 minus 2 sine squared. I can also take this one up here, so I've got cosine squared a minus 1 minus cosine squared a. And now when I do that, I can add like terms and I get 2 cosine squared a minus 1. These are the 3 double angle identities that go with cosine 2a. This is basically proving that the left side equals the right side. We can't do anything with sine. So what we're going to do is we're going to take and expand the sine 2x, which we know from previous development of this identity, it equals to 2 sine x cosine x. So the sines cancel. Now what's 1 over cosine? Well, that's secant. So we end up with secant x over 2.